Hello, let us solve the first problem. So here we want to calculate this definite integral. The integrand is x e to the power of x squared. So you see that this is the product of two functions, but the good point is that this part of the integrand x squared, when you differentiate it, it becomes 2x. So 2x is more or less the same thing up to a scaling factor. Whenever this happens, the best method for integration is the method of substitution. Okay, so here we say let x squared be u. Okay? And then of course, if x squared is u, I differentiate both sides. The left-hand side, the derivative becomes 2x and then dx. The right-hand side becomes du. But if you go back to the integral, you see that you have this combination of x dx. So I want to find x dx from this relation because my goal is to write my definite integral wholly in terms of the new variable u. Okay? So then this motivates me to divide everything by 2. So x dx becomes 1/2 du. So now, instead of x squared, I can plug in u, and instead of x dx, I can write 1/2 du. I should also take care of these limits, because these limits are the limits for my old variable x, but I want to have my limits for my new variable u. Of course, this is also clear, because when x is equal to 1, I want to see what u is. I plug x here, x 1 to the power of 2, which is 1. So when x is 1, u is also 1. But when x is equal to 2, for the same reason, u becomes 2 squared, which becomes 4. Okay? So the question mark here is my integral becomes equal to the integral. Instead of having from 1 to 2, I will have it from 1 to 4. Yes, so it goes from 1 to 4. Instead of e to the power of x squared, I can write e to power u multiplied by, instead of x times dx, I can write 1/2 times du. Okay, but of course you know that this is a multiplicative constant for my integrand, so I can pull it out. So this becomes 1/2 the integral from 1 to 4 e to power u du. But I need a primitive function for e to power u when u itself is my variable. So that is simple. It becomes e to power u itself. This becomes 1/2 e to power u, but I have to calculate it from 1 to 4. So this means that I replace my variable u with the upper limit 4, and then I replace my variable u with the lower limit 1, and then subtract these results, and of course I have a coefficient of 1/2 there. So if I do that, it becomes 1/2 e to power 4, e to power 1, and then subtract. And of course I can write this as e to the 4th minus e divided by 2. So that would be the answer to the first integral. Okay, now let us go and do the next integral. So if you have practiced your lesson a little bit, immediately, hopefully you realize that this is the integration by parts. So for integration by parts, let me write the formula here for you. So we know that for the indefinite version, we have the integral of u dv is equal to uv minus integral v du. And if I want to write the definite version of that, so then I will have integral from a to b u dv is equal to u times v calculated from a to b minus integral of v du calculated again from a to b. Okay? So one thing that you need to know about the integration by parts is that this formula is always valid. So it reduces this integral to another integral. So in order to be able to solve this integral, I need to be able to solve that integral. So this technique of integration is useful only if this new integral is simpler to calculate than the original integral. So this formula is always valid, but it is not always useful. Okay, so you have to practice a lot actually to be able to realize in which way I have to define my variables for the given integral, so that when I use the formula of integration by parts, the new integral that pops up is easier than the original integral that I have. For example, in this case, if I take this to be my u, this is one of the options possible. The rest of it I will take dv. So, okay, by experience I know that this is a good idea to take this one u, not this one u. Of course, technically I can also take e to the power of minus x to be my u and x dx to be my dv. But then if you do that, you will see that you get, of course, you always get a correct equality, but the integral that you generate in this way will be harder than your original integral. Actually, I really recommend you to do it yourself, the other way around, to feel why this is going to be the case. But in this case, I take this to be u, so my u is actually x, but you see that I also need du on the other side, so I calculate du, so du is just dx. And then this part is dv, which is e to power minus x dx. Then if you look at the formula that I am going to use, I also need v somewhere here. So this motivates me to calculate v from this relation. So then it means that v is equal to integral itself from e to pi minus x dx. The integral of e to the power of minus x dx. And then hopefully you know that this is a very simple integral. So this becomes minus e to the power of minus x plus a constant. But that constant is not needed here. Whatever you choose, this will work. And then, of course, this is also described in atoms. So why that constant is not relevant here. So I choose the simplest one, which, of course, is 0. So I have u, I have du, I have dv, now I have v, so I can use this formula. Okay, but I will use the definite version of that because I also have limits. So then the integral from 1 to 2 x e to the power of minus x dx is equal to u times v. This is your u, which is x, times v. I just calculated that. It is minus e to the power of minus x. So let me put the minus sign here. And then I have calculated between the given limits from 1 to 2 minus integral from the same limits 1 to 2, but this time v times du. So what is v? V is negative e to power minus x. So I have to put negative e to power minus x here, but that negative sign, I pull it out and it becomes positive here. And then I multiply it by du. So what is du? Du is dx. Okay, then I have to calculate. Is this successful? Is this substitution that I chose here a successful one? I would say yes, because this reduced my integral, original integral, to calculating this new integral, which hopefully you agreed with me, it is simpler than the original integral. Okay, so then I have to do some very simple calculations. So this one, I put 2 and 1 here. So for example, let me just write it like this. I put 2 here, it becomes minus 2 e to power minus 2. I put 1 here, it becomes minus e to the power of minus 1. Okay, and then plus. This integral is also simple to calculate. The primitive function for e to power minus x is minus e to power minus x. So again, this becomes negative e to power minus x. But still, I have to calculate it from 1 to 2. Okay? So here, I take this one, minus that one. So this becomes minus 2e to the power of minus 2. Minus this becomes plus e to the power of minus 1. And I do the same thing here. So I put minus 2 here. I put 2 here, it becomes e to power minus 2. Then I put 1 here, so it becomes minus e to power minus 1. And then I have to simplify this expression, which is simple, yes? So if I multiply this minus sign in, I will get minus e to power minus 2. I have minus 2e to power minus 2 here, so it becomes minus 3e to the power of minus 2. And then minus minus plus, I also have one of them here, so then it becomes 2e to the power of minus 1. And this is the answer to this integral. Okay? Thank you very much.